Hello, I'm Josh Starmer, and welcome to Human Stories in AI with StatQuest and Lightning AI. In this series, we'll hear about the career journeys of passionate AI experts. From their humble beginnings to conquered challenges, we'll be inspired by the real-world experiences of professionals thriving in the ever-evolving AI landscape. Human Stories in AI is brought to you by Lightning AI. Code together, prototype, train, and deploy AI web apps, all from your browser with zero setup. Personally, I love Lightning AI because it makes it super easy to use and learn from the StatQuest coding tutorials. Just go to the webpage, click on the Run button, and bam! You get code that you can play with without downloading anything or installing any packages. Today, we have special guest Achal Dixit, a data scientist at Delhivery, the largest fully integrated logistics services in India. Achal solves problems using data, statistics, and machine learning with a focus on business and people. Before Delhivery, Achal was a Business Technology Analyst at ZS, and before that, Achal was a research assistant at Imperial College London. So, without further ado, Achal, can you tell us about your journey to where you are right now, Delhivery? How did this all start?
I've been always intrigued by the field of computer science since I was a kid. So even though when I was in school, so I had that in mind that I had to do something with ML or AI when I kind of venture into whether it's academics or in industry. So I think it was pretty much clear for me in the beginning, but I didn't know how to do that. So the best advice I got from my teachers, from my parents, it was just to pursue computer science. Because doing engineering in computer science has been the most, I would say, straightforward path for anyone in India as of now. So a lot of folks are enthusiastic and they are looking forward to pursuing engineering specifically in computer science because we all know it's a field that's booming not only in like monetary and fiscal terms, but also in kind of the innovation that we keep seeing every day.
That's true.
So that has been a pinnacle for everyone. So mostly it started in first year. I got into an engineering college and rather an institute. So it started with me pursuing bachelor's in computer science. I took some mathematical course, but if I have to pinpoint at one thing that started my journey towards data science and statistics was the moment that COVID hit.
Oh, really? Okay.
Yes.
Tell me about that.
So what happened is lockdowns were announced nationwide.
Yes.
So we had a lot of migration from offices to home, from schools to home. So similarly for us also, all our teaching went online, all our studying went online. And I got it. So I have been really passionate about doing things. So putting in terms of RL, I would say it's like exploration versus exploitation dilemma.
Okay.
So it's a simple thing where you explore with n coefficient and n minus delta times you exploit whatever you have learned.
Okay. So you're learning just one step ahead of how and you're exploring, and then you have tools and you can use those tools to do new things and new exciting things.
Exactly. That's how I would define my thought process behind learning and doing things. It's like I learn and I quickly move the coefficients around for my n and for my delta. So then I exploit with n and explore with delta.
Yeah.
So that's how I would put it. So what happened is I was very enthusiastic as a student to participate in hackathons because they are challenging. I like to take challenges and solve them in ways that I don't know. It's just fun for me. It's like a puzzle. It's like a kid solving a puzzle. So that has always been the case for me.
I love it. I have a confession to make. I find nothing more intimidating and scary and frightening, and I have nightmares about hackathons. There's just, my hands are sweating just thinking about it. So it's actually cool that I'm talking to you as someone who's like, I love hackathons. They scare me to death.
Okay, so I have participated in a couple of them, and it was the MIT COVID-19 hackathon which started the whole research. Ideally, I got into research because of that. And from research, I got into data science and a job. So let's take one thing at a time. So I met with a couple of researchers from University of Michigan. So they are a very good friend of mine. And we all decided to participate in this hackathon organized by MIT.
Okay.
And there I slowly realized like how clinicians actually use statistics.
Okay. What was the problem you were working on? Can you describe that?
Yes. So the problem that we were working on was kind of predicting the ICU times.
Okay.
So how much time a patient would be blocking an ICU for? Because there was a huge queue. If we go
Yep.
back to 2020, there was a huge queue for patients lined up to get admitted to ICUs.
Yeah.
So we started from solving that problem, but we ended up solving another problem. What we did was, yes,
Yeah, that's isn't that the way it always is?
exactly, exactly. And it was so much fun for me, and it was such a great learning experience because I was
Yeah.
able to see firsthand how the clinical data looks like.
Yeah.
So, how the clinical data looks like, how researchers and statisticians and
Yeah.
specifically clinicians look at that data and make use of that data.
Yeah.
So, we had demographies, we had symptoms, we had data on symptoms, demography, and previous comorbidities of the patients. So, they were all lined up, and we simply ran a logistic regression. We
Okay.
wanted to predict
Yeah.
if you were to be sick from COVID,
Yeah.
how sick you would be,
Yeah.
whether it will be severe for you or not.
Okay. That makes
So,
sense.
so given your comorbidities, symptoms, and your previous background, all these attributes, we were able to predict with pretty good accuracy and kind of other metrics
Oh, I
that
love it.
if you were to catch COVID, how bad it would be.
Yeah.
So you need to take more precautions.
Yes.
So that's the end goal of it. And then we ended up kind of publishing that whole research into one of the very good journals, the American
Oh.
Journal of Emergency Medicine.
Oh, awesome. That's fantastic.
So that was the first publication I got, and I was in my second year.
That's
Uh, I-
amazing.
yes,
Can I ask a question?
yes.
How many people participated in this hackathon?
So over 800 people participated, I guess, and we won that hackathon as well.
And you won it.
Yes.
Out of 800 people, a
Yes.
second year student with your team won the hackathon.
Yes, I mean most of the work, like on the research side, was done by my friends who are scholars at University of Michigan.
Uh-huh.
Charles, thank you. I mean,
Yep.
if you're seeing this, so that's one thing, and yeah, so that got me into research, and I was really excited that okay, this is research, it's problem solving because
Yeah.
I had a very different idea about research in data science, machine learning, or surrounding subjects.
Yeah.
Being in computer science, I was like, okay, it kind of seems intimidating, boring.
Yeah.
Probably it was kind of once you go into research, you feel anxious.
Yes.
But to me, it seemed like, okay, you have a problem, you solve it, you
Yeah.
give you proofs that you solved it, it's research.
That's it. Bam.
Exactly. Yeah. And I was like, okay, so whatever I've learned so far, how can I
Yeah.
exploit it to probably do more research on the
Yeah.
similar topics that I've done? And that's how I got really very interested in research and data
Okay.
science.
Okay.
So that's how data science became the center of my interest and something that I really wanted to pursue.
Okay.
Because for me, being a computer science student, it
Yeah.
was two things were very simple. That I had that core technical understanding. I had
Yeah.
programming experience. I had my technical side pretty fundamentals pretty strong.
Yeah.
So I can virtually enter into any domain at
Yeah.
that point and make use and exploit my tools and learnings
Yes.
in order to make some progress in that field.
Yes.
And I just love the fact that the interdisciplinary approach that we have in terms of using statistics and data science
Yes.
and AI. It was so good. So that's how I ended up. And then later on, I took officially the course of machine learning through my third year in engineering. And there also, we got a project, but I take my project seriously. As I said, I love hackathons. I ended up doing a couple of, I started with literature review. I read a lot of papers. And that's how I found that, okay, I can solve one problem. And the problem being, there's a gray area when clinicians diagnose heart failure.
Okay.
So there's a gray area because the metric that they use to define heart failure is called ejection fraction.
Say that again.
Ejection fraction. So how much blood does the ventricle pumps out of the heart?
Got it. That makes exact sense. Okay, I got it now.
Yes.
Yeah.
But this metric has a flaw that they don't know how to classify the ejection fraction between 40 to 50, or let's say 35 to 45. So it is considered a gray area. And I found this just by reading a lot of literature on it. And then I thought, okay, can we solve this if I have good enough data?
Okay.
And by chance, I got a good data set from one of the PhysioNet websites, which it hosts open data sets. You just need to cite them if you use.
So what you're telling me is there was just a public data set that you could just download and play with on your own. You didn't have to like network with a bunch of cardiologists or
No.
anything. You could just get this data set and just start seeing what you could do.
Yes.
Okay.
So I figured out, okay, so by in back in the course, the goal was to kind of just build a machine learning model that does a classification. But I took a different approach. I went like, okay, let me go ahead. If I'm doing it, why not solve a real problem?
Okay. Oh wow. I love it.
So I went ahead, did a lot of literature review. Somehow I gained good enough knowledge of a little bit knowledge on cardiology as well, like how
Okay.
they diagnose, how the prognosis is.
Yeah.
So I listed the attributes. I went down, I did a nice exploratory analysis, and
Uh-huh.
I figured that there was some features that were highly correlated with how the gray area looks like.
Okay.
And hence, I was able to use some AI techniques like active learning and semi supervised learning to
Okay.
classify that gray area into primary types, whether less than 40 or more than 50, which is heart failure with reserved ejection fraction and a heart failure with preserved ejection fraction.
Oh, okay.
And I titled the paper Demystifying Heart Failure with Mid Range Ejection Fraction.
Uh-huh. And
And I published it in one of the IEEE scoped conferences, which is Computing in Cardiology. It's a pretty old conference, like 48th or 49th Computing in
yeah.
Cardiology conference. I got really good feedback that, okay, and to me, I don't know, it was simple
Yeah.
because I was able to find a problem.
Yeah.
I was able to quantify what methodology I know that I can use
Yeah.
to solve that problem.
Yeah.
And then I just needed to do experiments.
Yeah.
So that's another paper in my hat that I just got because I was simply interested.
And this is your third year. So
Yes.
you're in your third year, you've got two publications.
Yes.
I mean, this is pretty amazing, right?
I mean, it's just me being curious. So I think I was genuinely interested in the subject, and
Yeah.
things kept aligning for myself. I got lucky. I read right papers, found right problems to solve, I would say.
I can ask a question. So when you were experimenting with different methods to analyze this data, did you kind of know specific methods you wanted to try, or were you just like, well, I've got a whole bag of methods, I'm just going to try them all? What was that process like?
Actually, I was from if I look at that problem again
Hmm.
from where I am now,
Yeah.
I was quite immature. I did not know what a parametric test is, what a non-parametric test is.
Okay.
I did not know what this distribution is and what
Yeah.
tests can be applied on it. So I kept learning. Like I just intuitively thought that if I were to visualize this kind of data, what's one transformation I need? So I
Yeah.
went back, read about it, saw your videos
Yeah.
on PCA, UMAP, uniform manifold approximation and projection, and then I visualized and tried to gain insights from what the data tells me.
Okay.
And once it kind of showed a good inclination towards my hypothesis, I went ahead for different techniques. So yeah, I just proceeded like learned, applied.
So it
That's
was
the
like learn, visualize, and then once you can visualize what's going on, you had a better sense of what the next steps were to.
exactly.
Oh, fantastic! I love that. Yeah, that's what I always tell people, and they're like, what should I do?" And I go, visualize. Try to graph it, try to plot it, do whatever it takes, so you can look and
Exactly.
see what the data look like.
Yeah, because two of the features that I really that kind of clicked and lit the bulb in my head
Uh
was
huh.
if when I plotted creatine kinase versus one of the other features that I had,
Uh huh.
and the gray area, the people falling under the or the patients falling under the area of mid-range ejection fraction, they were not isolated how you would imagine on a linear scale of ejection fraction.
Okay.
They were evenly spread out. So I made a hypothesis that maybe it's just the flaw of a metric
Yeah.
because metric makes us visualize it in a linear scale,
Yeah.
and those people do not lie on a linear scale. So can we classify?
Yeah.
So can we classify? And I converted it into a binary classification problem and ran some semi-supervised validation, and it worked.
Oh, that's fantastic.
So that was one of the preliminary things I did, and that's how it just kick-started by itself. I was like, okay, this is it. I feel I'm good at it. I'm gonna continue doing this.
Okay. Okay. So you're in your third year. What's next?
So basically, so I was also quite a lot oriented towards applying what I've learned, as I've
Okay.
mentioned. So I try to convert this whole research into an actual application that can be used in India. So India is
Okay.
not very heavy on your use of EHRs or electronic health records. So I try to build a product where you can build a EHR on fly. You can load all the patient data on there, and all these AI algorithms are going to run on backend on those patient data,
Mm-hmm.
and they are going to give recommendation to the clinicians that probably, hey, you should look at this. This is what I suggest. So I'm not doing anything. It's just suggesting.
Yeah. Uh-huh. Sure.
Hey, probably you should look at this. So
Yeah.
it's kind of a suggestion, and that idea went into another hackathon. We did not win it, but we did not ended up winning the hackathon, but we ended up in top four finalists at
Okay.
Microsoft Imagine Cup.
And how many participants were in that?
Probably more than 1,000, I guess.
Whew. Top
It
four
was,
is pretty amazing.
yeah,
Wow. So you were like, you not only do you enjoy hackathons, it's like something about it like
yeah. I mean,
fires you up in a very creative and productive way. Like maybe for you the pressure of like get it done in the next 24 hours or 48 hours or however much time you're given is exactly what you need. You need that like
yes.
that time constraint, and all of a sudden you can focus all your creativity and all of your energy and bam, get
Yeah,
it done.
one mindset that has really helped me in doing that is I don't think about the outcome.
Okay.
I just do evidence-based stepping. I
Mm-hmm.
step if I have good enough evidence to move ahead.
Yeah.
And as I see it, I keep moving ahead, and somehow the product just finishes itself and something comes out.
Yeah. Well, so it sounds like you enjoy the sort of the quest, the journey of I'm not gonna. This isn't gonna be predetermined outcome. I'm gonna see where the data takes me. It's almost like a detective, right?
Yes.
Where you're just gathering clues and it could lead to anything, and you don't want to make a decision before you have the data and before you see what's going on,
Yes.
and that sounds very healthy.
Yeah, in a
Yeah.
sense, that has really, that's one thing that a lot of companies, when they are hiring for data scientists, they want to look for.
Okay.
Because in business, apart from academics, one thing that I've seen is people are more obsessed with the methodology
Sure.
and the outcome
Yeah.
rather than the impact it makes.
Yeah. What you just said right there, let's repeat it because I think it's one of the most important things that can be said right now, especially in the field of ML, data science, AI, statistics. Can you just say it one more time?
Sure. I would rephrase it like people are people get more obsessed with the methodology and the outcome rather than the impact the outcome causes.
That's amazing. I feel like that's so true. People are like, "Oh, what method are you using?" Well, I'm using this super fancy neural network. Oh,
Exactly.
that's really cool. And you're like, "No, no, no, no. It's not about the method. It's about the outcome." And
Yes.
sometimes that fancy neural network is the right thing to get us the outcome that we need. And when that's the case, we need to use that fancy thing. But sometimes it's a logistic regression. Sometimes it's k nearest neighbors. Sometimes it's like the most simple method that's going to have the most impact.
And let me give you an example here. So, what I mean by this is, if you go to a very enthusiastic, if let's say we have a very enthusiastic team of data scientists and analysts and
Uh huh.
ML engineers, they are
Yeah,
so somehow I don't know if it's appropriate to say they are seduced by the technology they have.
that's right. Yeah,
They are completely locked in what they're doing and they believe in it and in all good faith. It's
yeah,
perfect.
yeah,
But let's say you're using a neural net based method called TabNet.
yeah,
You train it, it takes a lot of time to train. And on the other hand, you have a simple tree based method, let's say XGBoost
yeah,
or random
yeah,
forest. The training time of the two is wildly different.
yeah.
And let's say you are able to get 5% more accuracy on the other part. on tablet because it's a deep neural network and it's a better methodology and you end up getting better results. But I think being in industry and solving problems for real world, you need to include other factors as well, like cost. How
Yes.
much it costs for me to train tablet? It
Yeah.
needs GPU, it needs more time.
Yeah.
Probably the cloud compute that you're using might ended up costing $1,000, which you might not save by having that 5%
That's
increment.
right. That's right. That 5% may not compensate for the extra time. Time is a big factor. Money is a big factor. We need to keep track of both those things. And sometimes it's better to sacrifice a little bit of accuracy or something like that if it means we can save time, save money, and just like with any model. I think a lot what people also forget is that it's not just about the initial training. It's about maintaining that model
Exactly.
and
How can I explain that?
retraining it every so often. And if you have something that's really expensive and really time consuming to train, you're not going to want to like update it every month or every couple of weeks or
Exactly.
whatever because it's going to be too expensive.
Yeah, the time to production, the maintenance that goes in, the amount of learning for different teams. So let's say the development team has a higher learning curve for a method, even though it's better. So we tend to trade it off for underperforming model if it does not require a lot of different infrastructure to be pulled in, a lot of different teams taking a lot more time to bringing it to production. So I think those are most of the things that companies are looking for data scientists who understand.
Yeah.
I'm just having very good grasp on theory.
Yeah. And they don't just want to use the latest, greatest. They want to use the tool that's going to solve the problem.
Yes.
And that could be the latest, greatest, but it could also be
Yeah.
something much simpler.
So
Love it.
in a sense, a good data scientist, I would say, is not the one who not only they understand the theory fundamentals, methodologies, the different algorithms that are out there, because somehow the open community and open source has democratized a lot of different algorithms to be used by people who don't know much about theory. So that does not sets you apart. What sets you apart is how you can translate a business problem into a maths problem and then use those tools in the most optimal way to solve without incurring a lot of costs.
Yes. I love it. I love it. Well, can you tell us a little bit about what you're doing now? Now that you're a data science at Delhivery, what are the kind of things you're doing now?
So most of the things that we deal, so the business is simple. You take a box from one place and you send it to the other place.
Yeah, yeah, super simple. There
Yeah,
could be no complications to that.
exactly. I mean, so most of the work that goes in logistics
Uh-huh.
has to strongly correlate with optimization research.
Okay.
So there are a lot of MILPs, mixed integer linear programming problems. That kind of approach is used to optimize the facility location, to optimize the rider assignment, who is going to deliver which packet where, and
Okay.
how many packets at once. So assignment, load assignment, facility location, and vehicle routing. For all these kind of stuff, MILP is still the best approach because you can explain it. Because
Okay.
it's not a black box, it's a white box.
Okay.
There
I'm
are
gonna be I'm gonna be honest. I don't really know much about optimization right now, so I'm just gonna like maybe let me see if I can see if I understand what you're saying. You're talking about so there are some. I guess these are relatively old methodologies
yes,
for optimization that
yes,
you can use to figure out everything from where things should be warehoused to how many packages each deliverer should be taking.
yes,
Um, and those are some of the tools you're using right now. Are these maybe not state of the art, but relatively tried and true,
yes,
simple technique? Relatively simple
yes.
that are explainable. Some methods, like neural networks these days, are like black boxes, and it can be difficult to understand why it's making a decision or why it says we should do this thing. So you're using these explainable things so you can understand and make choices and decisions based on that.
Yes. So
Oh,
to put it
perfect.
simply into a single sentence,
Yeah.
you have, let's say, X variables, X number
Yeah.
of variables. You form a linear equation out of it. You
Okay.
form a linear programming problem out of it. And then
Okay.
either you maximize it or minimize it.
Okay.
That's all.
No problem.
Yeah. I mean, that's
I think
oversimplifying it.
I think I need to do a stat quest on these things.
For sure, it would really help a lot of people.
Yeah.
So now where I'm using machine learning, it's mostly statistical machine learning because we
Okay.
have tabular data here. Now, I would not directly talk about the problem, but rather I would take an analogy to explain
Oh,
like
sure.
what kind of problems we are solving. So one of the problems that is really interesting to solve is, let's say you have an ice cream business
Okay.
and you have opened your ice cream stalls in 10 different cities.
Okay.
Are the most crowded places. That would be the first place you want to go. How do you know how many ice creams each ice cream parlor needs to sell optimally? So let's say the ice cream stall A is selling 70 ice creams a day.
Okay.
Is that optimal or can we improve? How do you benchmark that? Because it will be the problem will look like, okay, in city A, let's say in California you're selling 100 a day, but in
Yeah.
New York you're selling only 70 a day. So is this a function of the city, or can we do better in New York because we are selling 100 in California?
Yeah. That makes sense. So, for example, maybe in New York, it's colder and people don't want as much ice cream, but maybe in sunny California, where it's, they're in LA and it's hot and they're like, oh, I need an ice cream. So maybe you're just going to sell more because of the climate differences. And you could maybe put a lot of effort into trying to sell more in New York, but you may not get much return because
Right.
you've kind of saturated the amount of ice cream people can
Right.
eat there.
Now let's complicate the problem a little bit. You
Yeah.
don't make your own ice cream. You buy it from some third party. So you have
Okay.
100 different flavors, 100 different brands.
Oh, I see.
So probably the client mix is different.
Yeah.
That's why the issue is coming.
Yeah.
Every day you have a different person selling the ice cream.
Yeah.
A little bit
Some
more
people are
complicated.
friendlier than others.
Some people might not want to sell where the previous person was selling. They might
Yeah.
want to put it in another block.
Yeah.
So you see how this can be directly mapped to logistics.
So many variables.
Yes.
So many variables.
Now,
Yeah.
two problems come.
Yeah.
First problem is, how do you benchmark it? Second, if it is not meeting that benchmark, then why? The causality. What's the causality?
Yeah.
So this is a very interesting problem that we are trying to solve because the business needs to understand whether the performance in that specific area for that unit is good or not.
Yeah.
If not, how can we drive that up?
Yeah.
You do that, you instantly help business grow and optimize their costs and efforts being put into that unit. So how we are solving it, you take all the variables, you get a good enough data set because see, modeling is not the center of it.
Okay.
Again, I'll say how you translate business problem to a mathematical problem, how you find good enough proxies for the data you don't have. How do you estimate different variables empirically and substitute it for something that you don't have? Because
Yeah.
more than often you'll be able to map your problem, but you won't have good enough data.
That's right. Yes. I feel like that 99% of data science is trying to get good data.
Yes.
Yeah.
So I think most of the work and the mental rigor that goes into that is figuring out how can we solve with the limited data that we have, or how can we substitute and get better proxies for the things that we don't have,
Yeah.
and what reasonable assumptions we can make
Yeah.
with that fall within a tolerable threshold of error that we are accepted that is admissible. So what we did is we simply take a nice good data set. You have all your variables in people, places they have been in past, some historical figures, how you plan that city, how you map that city. We use it's a open public thing called Uber H3 hexagon. You try to create feature out of it that each individual locality, whether this locality likes ice cream or not, this locality likes ice cream or not, how much ice cream I've sold in this locality, whether I've visited this locality in past or not, and how the people have been in response to it, whether these people order more ice cream, expensive ones, what brands do they like, what brands after eating once they have never came back to us, Probably the brands that I'm buying from, I need to get rid of some of the brands because they are bringing our image down.
Yeah.
So all of those factors you turn into features, and it's not a very standard approach. This is a very hacky way to do things.
Mm-hmm.
So you train a tree-based model out of it. It understands the pattern, how the ice cream has been sold, where, and it understands the patterns of client mix, ice flavor mix, people, number of ice cream sold, frequency of it, and then we do Shapley analysis on top of it,
Okay. Okay.
which is a game theoretic approach. It tells you
Yes.
how much each feature contributes towards that prediction.
Mm-hmm.
The big assumption that we make here is model is good, the data it's trained on was optimal.
Yeah.
And then you simply compare it with current rate, and you can kind of get some directional inputs where the improvement needs to be made and what benchmarks to set.
Okay. So, just a quick question. So, how do you, I mean, if you're going to assume that your data is optimal, how do you know you're at least in the ballpark of that?
So for that, that's another myth that a lot of people who are trying to get into data science have, that it's all about modeling. It's not. Modeling is just 10% of it.
That's right.
So you do a lot of exploratory analysis.
Okay.
You have a hypothesis. Let's say I say affluence affects sale of ice cream.
Yeah.
How affluent that area is. If people are rich, they're gonna buy more expensive ice creams.
Yeah.
So I made that hypothesis. Now I go back, I look at my sales, 6 months of historical sales, and I try to see what rich localities are there and whether that correlates with increase in average order value.
Okay.
If that's true, it's a good indicator, and let's include it.
Yes. Oh, I get it. I get it. I see what you're doing. I see how. So for each, you come up with hypotheses of like, what do I think would affect ice cream sales? Then you can test each one,
Yes.
and the ones that come out as positives, you include that in your model, and the ones that don't, say like t-shirt color, that didn't correlate with different ice cream choices or anything. So you're like, well, we're going to get rid of that variable, and we're just going to use these essential variables and use that as sort of the gold standard.
Or let's say Josh was selling the ice cream, so we made $1 million. So that can be a strong correlation.
I think the problem, if I was selling the ice cream, I'd eat all the ice cream. Well, Achal, I want to thank you very much for being on the podcast and giving us not just one nugget of wisdom, but several throughout. And I also want to congratulate you on all your successes so far. It's amazing what you've been able to accomplish. And anyways, I just want to thank you. And and with that.
Thank you so much for having me on your podcast. And I don't know, I'm doing it for the first time, so I don't know what I did right or what I did wrong. If my
did everything
articulation
right.
was good enough for people to understand, for the audience. And I'm sorry if it is not.
Oh, come on. You were great. Fantastic. The important thing is I think we all learned a lot, and that's why we're here. That's the quest.